All right, guys, today's lesson is 10-6. We're going to talk about operations with functions. And so we've done all kinds of stuff with functions, right? We've graphed them and talked about the graphs and graphed them some more. And all we're doing in today's lesson is we're going to talk about adding, subtracting, and multiplying functions. Excuse me. So for our first example, let's look at adding functions. So if I said f of x equals 2x minus 3, so like that's a linear function. And my second function we're going to call g of x is 2x squared plus x plus 7. And that's a quadratic function. Well, maybe there's a situation that arises where I need to add these together. Oops. So again, I'm going to be adding these two functions together. And so what it'll say in the directions, it'll say something like do f plus g. Right? That's what it looks like when it's saying, hey, we want you to add these two functions together. And all I'm going to do quite literally is combine like terms. F is 2x minus 3. I said minus and I didn't write it. It's been a long day, y'all. 2x minus 3 plus g would be 2x squared plus x plus 7. Now we already know from algebra that we've learned quite some time ago that all I'm really doing here is I'm combining like terms. So I can see that I have an x squared term, and it's the only x squared term that I have. So that's going to be 2x squared. I can see here that I have two x terms, right? These are my two linear terms, 2x plus x. So that's going to be plus 3x. And then I have two constants, right? I have a minus 3 and a plus 7. That's the same thing as saying negative 3 plus 7, so plus 4. So when you're adding functions, you're quite literally just adding the two functions together. You're combining like terms, and that's it. Okay, so you also have to be careful whenever sometimes you can't combine the like terms, right? So this is just another adding example. So if I said h of x equals, excuse me, get my stuff out of the way here. H of x equals the square root of 5x, and k of x equals 7x plus 2. And I said, okay, let's add h plus k together. There's really not a lot I can do here. I'm going to add them together, right? The square root of 5x is h, and k would be 7x plus 2. Like, there's actually nothing I can combine there. So, as much as that hurts my feelings, like, this expression is your answer because you can't actually combine anything. So that is okay for that to happen. If you can add something, add it. And if you can't, then don't. So subtracting, honestly, guys, is the same thing. It's just we're subtracting. So here's the example for subtracting functions. Now, obviously, we have to be careful on this one because our negative signs can definitely get us into trouble if we're not mindful. So in this one, f of x equals 9x minus 2. And g of x equals x squared plus 4x minus 7. Okay, so in this time, now obviously adding the functions together, order doesn't matter when you add, right? 2 plus 5 is the same thing as 5 plus 2, but subtracting order is important. So if I asked you to do f minus g, I would have to be careful because I'm subtracting. Now how you attack this is kind of up to you. So obviously f comes first, right? 9x minus 2. And I like to go ahead and do minus in parentheses the whole g function, right? So all of it. That's why I'm really mindful about my parentheses. X squared plus 4x minus 7, right? So I'm subtracting. Again, this is the f function. If it makes you feel better, put that one in parentheses too, right? So the f function minus the g function. Honestly, I don't do that because it kind of messes my brain up a little bit. So here's what I'll do after that. Okay, I know I'm subtracting each one of those terms behind that minus sign in those parentheses. And like you guys, not a huge fan of negatives, so I'm going to see what I can do with this minus sign. So what I'll do is I'll change this to a positive. And technically what I'm doing here is I'm distributing the -1, right? So that would make that a -1x squared, a -4x, and a +7. So that kind of does all of that for me, rather than me getting confused and forgetting a minus sign. So now that I've done that, now I'm not worried about, like, I know exactly which term is negative and which is not. So just be careful with that. The answer to this one, okay, so I only have one x squared term. It is a negative, so negative x squared. I see here I have a +9 and a -4. So that is positive 5x. Again, I can see here that I have a -2 and a +7. That's going to be 5, so plus 5. So the point with the subtracting simply is just be really careful with those negative signs. Now you can choose to go and subtract each one of them individually, but I prefer this method personally just because I won't accidentally forget a negative sign if I choose to do that. So adding and subtracting functions, combining like terms, watch your negatives. Now, moving on, we also have multiplying. Now, obviously, multiplying is going to be a little bit different. Multiplying, I can spell. Really, all it is the distributive property. It's the distributive property. That's all it is. So I'm going to do 2 examples of this one because, again, I want to show you what happens whenever one of them's not so great. So for this first one, f of x is going to be 9x minus 2. And g of x is going to be x squared plus 4x minus 7. And it'll say find f times g. That's usually how it's written. So I'm going to do 9x minus 2 times x squared plus 4x minus 7. Now, just like with the addition, since multiplication is commutative, I could have put the x squared plus 4x minus 7 in the front. Really doesn't matter because multiplication is not big on order. All right, this is just the distributive property twice, right? I need to do 9x times each one of these terms, and that's what I'm going to do. So 9x times x squared is 9x to the third. 9x times 4x is plus 36x squared. And then 9x times minus 7 would be what? Minus 63x. So that's the 9x times each one of those terms in that trinomial. And then I can do the same thing. Now that it is a -2, so be careful with that. So I'm going to do the same thing with a -2. So -2x squared minus 8x and then plus 14. So multiplication usually just means a lot of the distributive property. Of course, I'm going to have to combine my like terms. So the solution for this one is going to be 9x to the third. 36x squared and -2x squared is going to be plus 34x squared. -63, right? -63 minus 8 is going to be what? Well, my brain is off today. 71x. And then I only have one constant down here, right? I don't have anything to add or subtract to the 14, so I'm just going to bring that down plus 14. So when you're multiplying functions together, all you're really doing is the distributive property and whatnot. Of course, just like that second example that I showed you up there with adding, every once in a while you're going to get this weird thing and you feel like you should be able to do something with it and you just really can't. I just want to show you what one of those looks like. So, like this one is a great one. If f of x equals 3 on the square root of x and g of x equals -2x plus 4. And again, I'm just asked to multiply f times g. I mean, I can multiply these, but like, they're going to look kind of weird. So I just want to show you what this one looks like. So 3 on the square root of x times -2x plus 4. Now again, I'm going to still have to use the distributive property, which is fine. That's not bad at all. It's just now I have to deal with the square root. And we have to remember the rules of working with roots. We've done that a few times now. Excuse me. So 3 times negative 2 would be negative 6, and then the square root of x. Plus 3 times 4 would be 12. Oh, I made a mistake. Let me go back and fix it. So here was my mistake. My brain, you have the square root of x and you have the x. So it's still negative 6, but we have an x that's not under the square root, right? This one. And then we have the x that is under the square root, this one. So as yucky as that is, you get negative 6x square root of x. Plus, now I can do the last one. 3 times 4 is 12, and then the square root of x. So as yucky as that looks, that is actually my solution. There aren't any like terms. And that is adding, subtracting, and multiplying functions.